Gloria, welcome back to the show.
Thank you for having me again.
Yeah, always great
Hi.
to chat with you, Gloria. I know you've got a lot of things you're working on in the space, and you recently took on a role as a maintainer as well. So we'll obviously get into that as well as all your work around the Mempool. So
Yes.
do you want to just start with? And we're going to keep this accessible for beginners. Um,
hmm
so you've taken on this role as a maintainer or one of the
hmm
maintainers of Bitcoin Core. So what is a maintainer? What do they do?
Yeah. So people often focus on the kind of technical, you have write access to the repository. But it's easy to understand why people get really fixated on that because I guess that's kind of the threshold of, okay, your keys got merged. But a maintainer, I would say, is more conceptually like any software project, someone who takes on the responsibility of maintenance of that code. And so, even if nobody was opening pull requests to request new features or point out things to Bitcoin Core, you would still have the job of finding bugs, fixing bugs, monitoring things upstream, updating dependencies, making sure we support things continuously downstream, cutting releases to do that on a regular cadence, taking care of what happens on the GitHub repository, so responding to issues and triaging pull requests and all those things, running CI, testing things, and yeah, so every software project requires maintenance. There's a really good book by Nadia Eghbal on this called Working in Public. I'm sure someone's mentioned that. And I think in the book, she estimates like up to 70% of software project activity is actually maintenance work. And I think actually it's more than that in Bitcoin Core because we are quite wide in scope. So we have everything from math libraries to managing ports, all the way up to a GUI. We have translations for dozens of languages. It's quite wide in scope. We support many different architectures, and on top of that, we do deterministic builds for all those architectures, right? We have a unique release process, so wide in scope, and we're very, very security focused. So what might not really be a problem in another project, we're like, we need to be on top of that. And that translates to everything as well, where like upstream, the maintainers are constantly monitoring upstream projects and almost like needing to make sure that things are going okay over there. And then if that's not very well maintained, then maybe we need to subtree something or we need to see if we can help maintain things up there. And then similarly downstream, I look at Lightning implementations, for example, because that's $100 million of Bitcoin is locked in those projects that depend on certain assumptions and Bitcoin Core being true. And so hopefully this gives you a picture of conceptually what is required to maintain Bitcoin
Sure.
Core. And
Yeah.
so, it's not mutually exclusive with the role of maintainer. There are a lot of people who don't have write access who do a lot of maintenance work. And yeah, so,
Okay, yeah, sure. So
hopefully
let's
this answers your
let's
question.
break some of that down a little bit. So just for listeners who are totally new, part
hmm
of the understanding with Bitcoin is we're operating in this open source environment, meaning anyone
hmm
can read the code, anyone theoretically should be able to contribute to the code. And there are different
hmm
ways you
hmm
can contribute to the code. One of those is by looking at something that you want to change in the code base and saying, okay,
hmm
I'm going to open a pull request. But that's only one form of contribution, importantly. Secondly, there's things like reviewing those pull requests, and there people will give feedback and say, oh, look, I think you need to fix this part of the code because it may be this, you might be introducing another security problem. And so then I guess part of the maintainer's role is
hmm
kind of also doing a bit of a review, but then also assessing the comments, the contributors, the reviewers, and then making that decision whether a particular change or something gets merged into what we call Bitcoin Core, right?
Yeah, exactly. And hopefully I've made it clear that the vast majority of changes are just like bug fixes or fixes of, something not being perfect. And then a very small minority are, maybe something like Taproot or something like Package Relay where you're trying to make a protocol change. And in that case, I think Bitcoin Core is very cognizant of, Bitcoin Core is not all of Bitcoin. And so there's a lot of community consensus that is required to make a protocol change. But also, okay, since it is a majority of the nodes on the network, then like we need to be cognizant of like if we make a change, how does this impact the health of the entire system? And so I think you had a question that you were going to ask me that I took a note on, which is, like sometimes you don't like Bitcoin Core doesn't make decisions on behalf of Bitcoin as a whole, right? And so, but that's a small minority of pull requests, but it's mostly just making sure the code is working properly.
I see. Yeah, and actually, just to touch on that as well, could you explain for us how do you like what's the difference between, let's say, a non-controversial change that's just kind of changing the color of a dialog box versus something that is more like meaningfully, oh, okay, this could really, if something goes wrong here, it could really screw up the way the P2P networking works, or the more controversial aspects. How does that distinction work?
Yeah, exactly. So we have consensus rules, which are validation of blocks. So I think people might have a good understanding of like, okay, every node on the network needs to be on the same page with respect to consensus. Another thing that would need community approval on is something like a P2P protocol change, which is how the nodes talk to each other. So if they're not using the same protocol messages, then that's a problem. I would say those are kind of the two, on the extreme side. And then, like you said, on the other side, you have the colors of the buttons. But even something like a translation string, like I said, our security bar is really, really high. So we've had issues in the past where someone translated something in a language that the maintainers didn't understand into, hey, if you have a problem, send your Bitcoins to this address, for example. And that's a security issue, even though it's at the very cosmetic level of the node software. Um, but sorry, to go back to what your question was, of like levels of controversy. So consensus is very much like you have to be monitoring how the community is responding to something, but those are very rare. But maybe something similar to that, like on okay, so we have a scale of like extremely invasive and dangerous to on the more cosmetic side. Maybe like a change to mempool policy would fall a bit closer on this end. But like a change in, the RPC help string would be closer to this end. But if we're going to change the public facing API, of course, we, need to have a proper deprecation cycle and whatnot. And so in that case, review and assessing, how reviewed something is kind of follows along, that stage where if it's a consensus change, you're obviously going to need community consensus. And then if it's an RPC change, then you make sure that the downstream users are, aware of something happening. But if something is like, oh, let's change the type from a signed integer to an unsigned integer, there is no behavior change happening. Or if we're changing the variable name because, this variable name is outdated because now it's a class that has more, it does more things in the code, we need to rename it or something like that. Those kinds of refactors are more for code health or paying down technical debt than they are user facing. And so these are kind of all the kind of considerations when you're thinking like how reviewed does something need to be in order to be incorporated.
Sure. And so for listeners who are new to this world, can you explain a little bit about the terms that you mentioned earlier, upstream and downstream? Like, what does that mean? What is dependencies, just at a high level
Yes.
for new listeners?
Yeah, definitely. Sorry for jumping ahead on that. So like every software has things that it depends on. So, for example, most software doesn't come with a computer to run it on. You need a computer with some operating system, and like Bitcoin Core, for example, needs to be able to create files, and so it'll ask the operating system, "Hey, can I create this blocks directory so I can store blocks?" And we have some other dependencies as well. So we need a C library we need a C++ compiler because the source code is written in C++. And so these are dependencies in that like we write the Bitcoin Core code, but then these are kind of black boxes or libraries that we pull in and we're like, okay, we rely on this working. We rely on an internet connection to make connections to other nodes, for example. And, some dependencies are like I said, like glibc, like a C library. And some are yet another GitHub repository where you can then go and see like the pull requests and the issues, and you can open and pull requests and stuff. And all of these are maintained to a different level. And all of these will also cut new releases. And they'll update things and deprecate things, and we have to respond to those changes. And so we are downstream users of that upstream library or repository. And so their changes affect us. And our changes affect downstream users such as LDK or LND, which require a working, I assume. Like we would there's different types of dependencies, right? There's like literal code that you're calling. There's like, oh, there needs to be a Bitcoin node running so that we can send data to it, but that's not necessarily part of the binary. So hopefully this gives a sense of the relationship of like you need other code. I've had people ask questions of like, how much code is in Bitcoin Core? Like, how many lines of code do you look after? And that's a very, very difficult question to answer because, if you think about it, really, for a Bitcoin node to work, you need, all of this, like this whole stack to be working properly. And Fanquake often says the easiest way to slip a vulnerability into Bitcoin Core is probably upstream, because we're definitely not watching Boost libraries as closely as we were watching our own repository. But you always have to make a sense of like, is this maintained or is this not?
Yeah, gotcha. And so as I understand that has been a thing in other ecosystems. Like I know people talk about like NPM, and there's like 1,000 different dependencies, and one little upstream error up there can kind of end up in your project because you're pulling this other thing. Now, as I understand, obviously Bitcoin Core is much more, let's say, conservative or reasoned about these things, and there's deliberate effort done to, let's say, reduce dependencies or remove them where that is feasible. But
yes,
just
definitely.
explaining the concept so people kind of have an idea about what that is. Now, I guess the other question that probably a lot of new listeners are just thinking, oh, well, hang on, Gloria, does that mean you control Bitcoin Core? Like, do you, like, obviously I understand that's not really how it works, but just for the sake of listeners who are new to Bitcoin, how would you answer that question? Like, do you control Bitcoin Core per se?
No, not at all. Or even if, so I guess we can walk through a hypothetical situation, which I don't think is realistic at all, because everything happens in public. As you said, it's open source. What if the 6 of us decided to merge a hard fork in Bitcoin Core, or like, do something crazy? What if we just deleted everything, for example? Well, then someone can just fork and make a new copy of all of the code, and then, maybe rally behind some reputable previous Bitcoin Core contributor or some other, whatever. And then just continue on. And then maybe you'd have like a day of like a bit of chaos. And then you'd just have the same code, continuing on. And of course, like, if here's another thing, right, is software, we don't have the power to auto push updates to Bitcoin Core users. That's not the case in other software. For example, like printers get pushed, auto updates all the time. But we don't have the power to force your computer to download and install the new release of Bitcoin Core. And so if we merge a change today, we would then, a few months from now or a month from now, create a release, and then we'd post it, and then all of the users would decide whether or not they're going to download it and install it. So we have very, very little control over what's actually run on the network. Well, I mean, maybe there's some like social influence or whatever based on like the trust that people have in someone who's been doing this for several years. Um, but like very little power over Bitcoin at all. Like maybe Bitcoin Core as like the GitHub repository at
Yeah,
Bitcoin slash Bitcoin.
github.com/bitcoin
Yeah.
slash bitcoin. Yeah.
But again, like that, you can easily make a copy. That doesn't necessarily mean what's running on Bitcoin network. Yeah,
Right.
like
And there are multiple implementations as well. There's like
yes,
libitcoin, BTCD, and some others out there, right?
yeah, Rust Bitcoin. Yeah.
Yeah. And so then
Hmm.
could you also just touch on, so you mentioned there are 6. So if you could talk a little bit about, I guess, as I understand, you might be a maintainer who's a specialist in a certain area. Like if you could just elaborate on that.
Yeah, exactly. So my scope is mostly Mempool and associated functionality. So Mempool, the data structure, mining, Mempool validation, the fee estimator, and then various surrounding areas. A bit of transaction relay, maybe. Um, and so essentially, this is the area of code that I've become very, very familiar with in the past couple of years. And so since the past 6 months to a year, I've been reviewing every single pull request that is open to this area. And I've also opened various pull requests to improve things or fix things in this area. And so, as far as I can understand, the other maintainers and maybe some other Bitcoin Core contributors, feel that I know enough to, be particularly asked to review and or merge things in that particular area. Um, and Fanquake is the build system maintainer, and Marco is his scope is test and QA. So he's constantly testing and fuzzing and monitoring and sanitizing and running CI and fixing CI and all those things. And he opens the most bug fixes out of all of us because he's constantly finding those. Chow is responsible for the wallet. Habasto is responsible for the GUI. So
So everyone has their domain where they're considered an expert, but that doesn't stop you from, let's say, working in someone else's area. It's just seen
yes.
like you are, let's say, taking carriage of this particular area that you're assigned for.
Yeah, it just means, if there's a PR somewhere and it's like, okay, this is the default person to tag for review. And, they'll be able to make, be able to tell you, like, here's what usually needs to happen in order for something to be merged, for example. Yeah.
I see. And so also, could you just touch on, I think this is another point that might be subtle and difficult for listeners who are new to this world, but
Hmm.
as I understand, the focus with open source contribution and being a Bitcoin Core contributor, it's yes, there's some subjectivity, but the aim is to be scientific and objective about how you do things and have a technical approach to things as opposed to subjective opinion about it.
Yeah, exactly. So in engineering, there's always trade offs. I think Twitter tends to overblow or maybe underestimate how much kind of back and forth discussion is appropriate when you're discussing various trade offs and in designing something. So what looks like arguing is really just we're discussing what's the best way to do this because there are multiple ways to do something. And in that case, maybe there's a bit of subjectivity, and in like maybe you prefer something to be more performant, whereas someone else might be extremely conservative and say, Bitcoin should not change very much. Whereas someone else is like, oh, we should be trying out new features as much as possible. Or, like people will have different preferences on the various spectrums of the space that we are exploring. But yeah, it's still like you're objectively saying like this has a runtime performance of this, and this requires this much memory. And so yeah, this is, I think, a good example is, for example, Mempool is by default 300 megabytes, and we want this to be very accessible for anyone anywhere in the world to run a Bitcoin node, right? And if someone is like, oh, let's add this new feature and it'll require every mempool to be 600 megabytes. And then someone else might be like, well, this is very much worth it. Whereas someone else is like, well, this makes running a Bitcoin node less accessible. And then so you're kind of exploring like those two, objective truths of like where on the spectrum can we like compromise, like what maybe like ideological value do we value more. So that's kind of where the discussion is usually framed around.
Yeah, sure. And as I understand, there's also a concern or consideration given for, let's say, people have built up a certain use case. And now, let's say some new technology has come or a new scaling improvement has come, and that might kind of undermine someone else's use case that they've already got out there. And so I guess that's also part of where there'll be, let's say, community debates back and forth about the viability of this and which should be prioritized.
Yeah, exactly. And so there are many spectrums on which to consider something, but one of them is kind of risk and how badly can we screw up Bitcoin if this is merged. And often that corresponds with utility. A consensus change, it's very, very high leverage because you're at the bottom of the stack and you're changing things. You can build L2 protocols that do wild amazing things based on just this one little consensus change. But if you screw this up and you've accidentally introduced a consensus change where now we have an inflation bug or something, that's a bit scary, right? So like we were saying, you have different levels of review and community consensus required. Like, yeah, it's risk is like always the huge, like, I think number one priority or number one thing that people are arguing about or discussing.
Yeah, sure. And I think maybe this is where there's also some subjectivity that enters into it, but at least it seems that as I've followed things, at least the discussion I see, it seems like people don't really want to do things that massively destroy someone's use case, or like it seems like generally changes have to sort of be like a win-win-win for the most part, or otherwise they
Yeah.
just won't make it in. Would you say that's fair, or would you disagree?
Yeah, so it'd be great if some things win-win. I mean, that's very easy to argue, right? It's like,
Right, but the
oh, this
difficult case
is
would be, let's say it's like mostly win-win, but like someone somewhere has to take a slight decrease, and then it becomes a bit of a debate, right?
yeah, so it depends on like what the decrease is. I don't know about like use cases, but I think in the scenario I mentioned where it's like, oh, now people with tiny Raspberry Pis won't be able to run Bitcoin nodes on them. I think that's a deal breaker. Although it would maybe be perfectly reasonable to someone else, and especially to other cryptocurrencies, where like you don't require accessibility as much. But yeah, like some things I think most people would consider fine, or some people would consider absolute deal breakers. And everyone has a different opinion. So yeah.
Okay, so as you've mentioned, a lot of the work is around maintenance, as in fixing bugs and just kind of keeping the wheels turning. I
Hmm.
think this is one of those things where maybe people online, you see online discussion, and there's people who talk about this idea of ossification. Now, I'd be curious to get your view on some of that, as opposed to what it would mean if there were no big changes to come to Bitcoin, but also contrasting that with what you're explaining, which is that actually a lot of the work is just maintenance anyway, so that there is maintenance still to be done.
Yeah. So I mean, so just if we did nothing, I think it would just not work anymore. So maybe some concrete examples. Like recently, we had a protocol change, which is a P2P protocol change, maybe a big deal. Not recently, of a adder v2 message, which is required in order to send IPv6 and Tor v3 addresses of Bitcoin nodes. So if we hadn't made that change, we would not be able to continue using Tor because Tor v2 would be deprecated, and then we have no way of sending Tor v3 addresses, and so you can't run a Bitcoin node on Tor anymore. So sometimes protocol changes are required to continue functioning in this very important way, being able to run on Tor. And so that's maybe a really easy to grasp example. But the vast majority is literally just like, bugs are found on a regular basis. There are 400 pull requests open, and a large portion of them are bugs. And some of them, there's different types of bugs, right? Some of them are like just data races, where like if the threads run in a particular order, they're scheduled a certain way on your OS, then you'll have a crash. And this is extremely rare, but like you would want to fix that. Like any software project would want to fix a data race. Or an unsigned like an integer overflow bug, for example. And these are like code quality things. There's no such thing as bug-free code. I will assure you of that. And yeah, so like even if we stop doing anything, it would just stop working. Eventually, like there would be no operating system supported. Eventually the upstream libraries would be no longer maintained. Vulnerabilities would slip in, and it would just be impossible to run Bitcoin Core. And so a great deal of maintenance work is required, even if we don't want to make any changes. And then the idea of like, how much change should we have in terms of features? Everyone has an opinion on that. I would lean towards the conservative side, just thinking about how much maintenance work is required. And, if you have this great big project and you only have, let's say, 30 regular contributors looking at it, then gradually you won't have enough people to be looking for the bugs, and then you'll have more and more of them, and then it'll just stop working or you'll be vulnerable to attacks. So yeah.
Yeah, right. So I think we could summarize it then as Bitcoin does not exist in a vacuum. It still has to interact with, let's say, operating systems, internet protocols, whether that's Tor
Yeah.
v2 being deprecated in favor of Tor v3, or even I2P, which was like another one where people were saying, okay, can we use this other way of interacting? So in that sense, there's always going to be maintenance required because there's just always change happening in the rest of the technology world. And so I think that's maybe something maybe people on Twitter or things don't quite grasp that element of how the system works and how the sausage is made, let's say.
Yeah.
And so I think the other point that's probably interesting as well is just around getting contributors into Bitcoin. Part of that is actually from that book, Working in Public. One thing that really stuck out to me from that book was this theme that it's always easy to get like a new pull request, but actually the real bottleneck is normally on having people who are capable to do review. So could you just elaborate a bit on that in the Bitcoin Core context?
Yeah. So we have a pretty high review bar, which stems from the focus on security, and it's all about bugs, because if you catch a bug in review, that's way easier than catching the bug after it's been merged and interacting with other things and whatnot. And so every pull request, it depends on the pull request, requires quite a bit more review time than time to write it. And maybe that's not the case in other projects, where it's just manager said write this feature, and then you wrote it, and then manager merged it. And it's just a B2B, like 50 clients software, and nobody's going to attack it. But in Bitcoin Core, we assume a highly adversarial environment. So if there is a bug, if there is a way for someone to crash your node, that's huge. That is really, really bad. And that's why review time, I would say that depending on the pull request, you need at least twice as much review as you need time to write it. And so that's why not every pull request gets merged, and why maybe newer contributors might take some time to acclimate to this development culture, because maybe they worked at the company that I kind of just described. And after it's been merged, that's also not the end of it, right? Because it'll interact with other pieces of software. And then if it's code that only one person understands, and then that person leaves, then suddenly we have code that nobody understands. And we don't know how, if another pull request is opened that everything touches everything, that touches this module, we're not sure if this is going to cause a bug. And so maintenance after something is merged is also a consideration. And so, that book, Working in Public, I think kind of talks about this pretty extensively. And I really like a lot of the language that is used there, and that maybe some people don't want to say this, but there are people who want to get a commit into Bitcoin Core and then be like, I'm a Bitcoin Core contributor, right? And that is not always contributing. So it's not always
Not
additive. It's not
productive.
always helpful. And in fact, it may take away review time from a bug fix, for example. And I want to be I really, really hope that this is not discouraging anyone from contributing to Bitcoin Core. But on the contrary, what I'm trying to say is the best way to contribute is to review, is to test, and everyone can contribute to Bitcoin in their unique way. I would say that in terms of helpfulness to accessible ratio, if you're a newer contributor, please come and review pull requests. Or if that's difficult, come to PR Review Club. So sorry, this is a plug.
Yeah, sure.
Every
No, go
week,
for it.
I help organize Bitcoin Core PR Review Club. Every week, we pick a PR that is open to the Bitcoin Core code base, and a PR is you can think of it as kind of a guided tour through some particular area of the code base or some functionality. So we'll break down the concepts, we'll link to pieces of code or documents that help you understand this. And then we'll go through various questions that kind of help build a mental model of how you can be very critical at looking at each commit and looking out for bugs and looking out for potential future problems that might happen if something's built on top of this. So we do that every week, and it's supposed to be for beginners, so everyone is welcome. Yes, please come and contribute.
Yeah,
To
so
Bitcoin Core.
listeners, I'll put the link in the show notes, and it's one of those things where I like that it happens in public, because there have been times where I'm just out of curiosity, I'll just kind of click through and read some of the discussion just to try to at least have some familiarity. I don't quite grasp all of it, but I at least have a look at it to get a rough idea of what's going on and what the discussion is on some of the changes of the day. And speaking of changes, I think it's probably we'll chat a bit about this theme as well. This whole idea of Mempools, package relay, and a little bit about that now. So maybe to back up and give the background on this, let's just start with some of the basics. So there's this concept of a mempool. So what is a mempool? Why do we need this?
Okay. So I think a lot of the interesting aspects of Bitcoin is when an ideological value turns into a technical problem to solve. So the ideology that we might start out with is anyone should be able to pay anyone in the world, regardless of what country they live in, their politics, what they say on the internet, yada, yada. And so in Bitcoin, we know, thus, we cannot have some central entity that is managing who is transacting with whom. And so we have a peer-to-peer network where each node can join, and they can kind of hide behind this huge network of anyone could be a miner, anyone could be someone who relays transactions or the sender or receiver, right? And so this permissionlessness is the kind of technological challenge, because the idea of okay, anyone should be able to join the network and send a transaction also means okay, this guy could be a bad guy trying to take down the network. So at the easiest level to understand is they could be trying to censor your transaction. They just drop it. Or they're trying to spy on you. They're trying to figure out like where exactly did this transaction come from. Or what I consider the most interesting part about Mempool is maybe they're trying to cause you to go out of memory, or they send you data and that causes you to just stall. You're just spinning in this infinite loop. And this is why Ethereum has gas, right? Is what we call in computer science a denial of service attack. And the mempool, concretely is a cache of unconfirmed transactions. Each node keeps a mempool of the transactions that are floating around and waiting to be admitted to a block. But it's also this precious, precious resource that each node has and has to protect from attackers. And so I don't know if I explained this very well, but this ideological value of permissionless, anyone should be able to pay anyone, translates into the technical challenge of how do you have each individual node participate in this distributed transaction relay network in an adversarial environment and protect itself. And so the definition of mempool is a cache of transactions and associated logic for validating transactions, deciding exactly what's going to go in and out of this precious 300 megabytes that you allocate for your participation in the network. And it's also very, very useful in other ways as well. It helps you speed up block validation because it is a cache. It helps you do fee estimation and all those wonderful, useful functionalities of a node. It helps you broadcast transactions with unconfirmed inputs, all those things. And I consider Mempool to be one of the most fascinating parts of Bitcoin and kind of underrated, to be honest, because it's so technologically fascinating. There's so many interesting trade-offs, and it is where it's like, well, it needs to be permissionless. It needs to be accessible. Anyone should be able to run a Bitcoin node, and that's where you like really start looking at trade-offs that are very interesting. So that's my little pitch.
Right.
For what
Yeah,
Mempool
and I
is.
think that's really that's cool. And I think so listeners, I don't know how familiar if you're an experienced listener, I'm sure you're well familiar. There are these mempool visualizers. So famously, mempool.space is probably the I would say the leading one today. But blockstream.info is also a memorable one or a well-known one out there. And you can visualize the mempool and you can see, oh look, these are all the transactions out there. And as you said, Gloria, the default is 300 megabytes. So then that's obviously there's all these different aspects to discuss, but that default 300 megabytes one can create conditions where, let's say, some transactions can, I guess, quote unquote, fall out of the mempool. But really what we're talking about is falling out of, let's say, a default mempool. So I guess to put that into a concrete example, we would say some big exchange or some big actor on the network has just dumped a whole lot of transactions into, quote unquote, the mempool, but really we mean the mempools of all the nodes, and such that if, let's say, I'm a pleb and I just put my 1 sat per byte transaction through and I've fallen out of the mempool, what happens to me?
Well, it depends. So if you are just trying to send a payment and maybe you signaled RBF, you can just make a replacement transaction and you're okay. But yeah, so mempools have limited space because we cannot reasonably expect every node to have infinite amounts of space. And that would be an attack vector as well. And yeah, so part of policy is basically a set of validation rules that we apply to these unconfirmed transactions that kind of help us guard this precious resource and decide, what goes into the mempool, our mempool. So each node has their own mempool to make sure that we've covered that. And so usually when your mempool gets full, you'll dump the ones with lower fee rate because those are less likely to be mined. And so having those in your cache is not really going to help you validate blocks because miners are going to choose the higher fee rate ones. So you're going to want to, keep those so that you have that in your cache. And so, yeah, when your very low fee rate transaction drops out of most people's mempools, That's usually okay for a regular user that uses RBF. It's not as okay for contracting protocols. So we have these L2 contracting protocols, such as the Lightning Network, where two counterparties who don't trust each other are able to, at a very highly scalable way, transact and private way, transact with each other by not broadcasting the transactions. So they'll sign a Bitcoin transaction with the spending conditions of, hey, if we're still on the same page next week, we'll have this amount of money. If you go offline, then I'm going to broadcast this on chain, and the contract terms are still available, are still fulfilled. And that's why we might think of this as a smart contract. And so vaults might be another example, or DLCs, discrete log contracts, where you essentially have a pre-signed transaction between untrusting parties. And they're going to sign this transaction far before they're going to broadcast it. Because the whole idea is you're not going to broadcast this, right? You're just going to settle this off chain, and then only if something goes wrong, you broadcast this transaction and get it confirmed in the Bitcoin chain. And that's why you get the same security guarantees, right? You're always able to settle on chain. However, that breaks down depending on maybe what's in the mempool, because you signed this transaction a long time ago and you put a fee rate on it, and you decided, okay, I'm going to broadcast in the future. And maybe we put 2 sats per vbyte because the mempool is completely empty, right? Or, there's not very many transactions in people's mempools right now. So it's very reasonable to be like, hey, 2 sats per vbyte or 5 sats per vbyte. But then if you go to broadcast and there was just recently, right, there was a huge dump of like dozens of blocks, like several days of blocks worth of, I think it was 17 sats per vbyte. And so you'd just be below all of these things. And typically in these contract spending conditions, it's like, okay, someone goes offline, you have, 144 blocks between, this time and that time to get the transaction confirmed. Otherwise, the other person can redeem their coins. But this is very time sensitive, but the time at which your transaction confirms depends on the fee rate, not really on how badly you want it, right? And so you need, as a security assumption, a way to reliably add fees to, or what you need is a way to get your transaction prioritized. And then the security assumption that we always rely on, which is quite minimal, is miners are economically rational. And so we want it to be such that on any transaction, you'd be able to add fees, and that directly translates to it's going to get confirmed. But if the transaction cannot be replaced and is below the mempool minimum fee rate, then you're out of options, because, up until quite recently, there was no way for most mempools only looked at transactions one at a time, right? So they'd see the really low fee rate transaction that was signed a long time ago,
and then just
and they'd
discard.
see the child, and then they go, bleh. And then the really high fee rate, they'd be like, well, I don't have the transaction it depends on, so I'm going to throw that away too. And so now we have package validation, which is being able to look at both transactions at the same time. And then the next step is being able to relay them together, because I guess essentially, if the client submits it to their node and the node has that in their mempool, they still need to propagate that across a few nodes to get to the miners, right? And so if you're only sending transactions one at a time, unless there's some very clever logic in handling orphans on the other receiving node, they'll probably still just drop it on the ground. They need to know to accept it as a package, and so that's where we have mempool validation changes, i.e., the logic of being able to look at transactions multiple at a time, and then the peer-to-peer protocol change package relay, which is getting nodes to be able to communicate with one another about like, hey, try these together. Trust me, it's gonna be a good fee rate. So
I guess then,
relay.
and I guess part of the complexity that we're dealing with, as you mentioned earlier, is if somebody was malicious, like let's say I'm a bad guy, I maliciously craft a package that I know will cause you to spend a lot of your CPU time. And actually, at the end of it, you'll realize, oh, wait, actually, Stephan was bluffing. There was nothing here.
Yeah.
I guess that's one of the difficulties you're looking at.
Exactly. Or another really important one that has essentially made this a very, very big project is a pinning attack. Okay,
So
like
what's a pinning attack? Yeah.
yeah, okay. Um, like we said, one security assumption is that for L2 protocols is that the transactions are going to propagate. And so if there's a way to censor those transactions from getting to the miners, then you have an attack, right? And so a pinning attack is a type of censorship attack in transaction relay where you take advantage of the policy rules that nodes have, and you find a little spot where, if you have this particular configuration of transactions, then either a conflicting transaction won't replace it, or this transaction is never going to get mined because it's going to stay at the bottom of the mempool, or it's just never going to make it into mempools. And so there have been a lot of RBF related pinning attacks that we've been talking about a lot. And so kind of package relay it kind of includes solving a lot of these pinning attacks, because it won't make very much sense if, okay, now we can talk about packages, but there's this way for attackers to always be
To
able
keep pinning
to
the transaction there.
pin packages. Yeah.
So as an example, I guess, so let's say we're in a Lightning context, and let's
Mm-hmm.
say, so you and I have a Lightning nodes or whatever, and we're connected with a direct channel. Let's say again,
Mm-hmm.
I'm an asshole or I'm a malicious guy, and
Mm-hmm.
so I guess the idea, you correct me if I'm getting this wrong. So let's say we have a channel open. I send some sats to you over that Lightning channel, but
Mm-hmm.
then I try to I maybe I notice, oh, Gloria's offline or something, and uh, I try to broadcast an old state and try to pin the old one, so that
Mm-hmm.
way, and then I guess I've heard it explained as to try and outrun the time lock, right? Like that 144 blocks. So that's kind of the idea, right? If I'm the malicious attacker, that's what I could potentially do in a fee pinning attack, right?
Yeah,
In a pinning attack.
exactly. So they can broadcast that one. Often the way to do it is to broadcast the transaction, and then you're allowed to have up to 101 kilovirtual bytes of this transaction plus all of its descendants. I mean, let's say you put a low fee rate on that, so it's not a fee bump actually. But then in order to replace this, you're going to have to replace all of these, this transaction and all of its descendants. And so that can get quite expensive. And so we would consider that a pinning attack. And part of package relay is like fixing, like, okay, let's make sure that, maybe they only have to replace up to 1,000 virtual bytes, or, whatever it is, so that, there's a little bit less variance as to what might happen when you're trying to broadcast your transactions.
I see. And so if we could just briefly explain RBF as well, so listeners who might not know, what's RBF?
Okay, so RBF stands for replace by fee, and it is a mempool policy that is implemented in Bitcoin Core and other implementations, where when we see two conflicting transactions, like they're double spends of the same UTXO or UTXOs, um, instead of just throwing out anything that conflicts and picking the first one, we will actually assess, like, hey, maybe this pays a higher fee rate and thus is more incentive compatible for me to keep in my mempool. And that has a lot of different rules around it, mostly for DOS protection. So we don't want to be like replacing the same one over and over again. That would be pretty poor network bandwidth spam. But there's a lot of mostly fee rate related rules. And so users can take advantage of the fact that nodes have this implemented in their mempool policy. And so if your transaction's taking longer than you want it to for your confirmation target, you can quote unquote add fees by replacing it with a higher fee rate version of the exact same transaction. And, it'll RBF its way to a miner's block template.
Yeah. And so I think depending on who you talk to, there are some people who don't like RBF, but on the other hand, I can see there are others, let's say maybe in the technical and developer communities, who are saying, no, we actually want, because we want RBF to be like a default thing. So could you just explain a little bit around
Mhm.
that dynamic for people?
Okay. Yeah. So the idea, I think, the controversy around full RBF. So, okay, sorry, let's back up. So, one of the rules right now is in order to RBF a transaction, to replace a transaction, the original usually will enforce that it had a signal on it to opt in to being able to be replaced. And that was kind of, as far as I understand, a courtesy to give everyone time to handle replacements in their logic. So, for example, if you're tracking payments by TXID, that you might struggle a little bit when replacements are very common, where it kind of messes up your tracking. So, you give businesses a bit of time, and, OpTech did a lot of advocacy around this, of being like, hey, like, here's how you handle, unconfirmed transactions. But at the end of the day, double spends essentially were always possible, right? Your business was always, it was always possible for you to receive a transaction with a payment, and then everyone else on the network to receive a completely conflicting transaction. But I think the idea was, some people were maybe under the impression that with RBF introduced, now you can double spend, or now double spends are more easy to do, or more common, or I don't know. And I think this mostly stems from a misunderstanding of how transaction relay works. Or like maybe not a very accurate risk assessment on businesses' part to bake in the risk of using unconfirmed transactions. So I think there is a use case for like unconfirmed transactions. Nowadays, you probably want to use Lightning, but if you're going to accept unconfirmed transactions in your business, you need to bake in the risk of there being a double spend out there, right? But yeah, so right now it's been 8 or 9 years since RBF was first deployed, and now it's quite common. There's quite a few, like thousands of replacements that happen every day. So hopefully all the businesses have caught up, and your wallet software is handling replacements. And now there are a number of pinning attacks that stem from like, I can't replace this because it didn't signal replaceability, right? And Antoine has posted on the mailing list quite a few explanations of these kinds of things. And so it's very important now for L2 security that we're able to replace things, or have some kind of policy that isn't what we have right now. But I think apparently, there is still a bit of misinformation out there about, what replacing means, or, what full
I see. Yeah.
RBF might mean.
Yeah. Or
Yeah.
certain businesses
So,
who maybe rely on that kind of idea because maybe they want to be able to, they in their mind, or maybe they have a business reason to accept that risk, right? So, I mean, I know,
yeah,
for example, companies like Bitrefill will do this kind of thing where they have, where
exactly.
that's probably the well-known example, where I think they will, because it's about delivering a voucher, and from their point of view they'll say, well, we want to be able to give the customer their thing straight away, but
Right.
here's what we'll do: we'll make sure that you are not signaling RBF on your transaction, and you've put above a certain fee rate, so that we can kind
Yep.
of mitigate our risk down a little bit. But I guess this is
Hmm.
kind of the longer term argument, which I understand you and perhaps other developers are making, is that no, we need to move to Lightning and use like more scalable, like, and as part of that, as to make those L2 and Lightning and things safe, we need RBF kind of more of a as a default, as a standard. Am I
Yeah.
summarizing that correctly?
Exactly. So the first time I met Sergey, shout out to Sergey, we had a whole argument about this, and he talked about like Bitrefill has business logic to handle risk, as a smart business does, and so yeah, like he's like, maybe we'll be fine, but it is nice that there is this opt-in thing, but yeah, like you said, there are reasons why you might want to not wait for confirmation. And so that's valid. I think Lightning is mature enough where that should be the implementation behind the scenes of accepting faster payments. And I'm not here to like tell other businesses how to do their business. But I'm here to say that full RBF is not necessarily more risky because it's always possible to have a double spend. It's there's always it's always possible that other nodes have full RBF already on, and they are accepting replacements without enforcing signaling. Um, but at the end of the day, if we if community is like no, and that comes from a solid objective like technical reason rather than a misinformation one, um then then I guess we have to stick with
What we've got now. Yeah.
opt-in signaling. Yeah, and
Yeah.
totally fine. It's just my opinion. um like it's been 8 years and we haven't merged full RBF, so like what do you
Well, I
yeah.
look personally. I obviously, if I'm in person or I'm doing small value commerce, I'll always prefer to use Lightning if I can because hey, it's just more convenient. But I understand there are, let's say, Lightning skeptics out there and people who, let's say, no, I just want to use my thing on chain, and um, so I'm just trying to reflect at least a little bit of the thought there. But I personally do believe we're kind of it's all the small value commerce is going to be done on Lightning anyway, or other, let's say, other scaling
Yeah.
methods. So
Yeah. So one proposal that I'm kind of cooking right now is to have another way to opt in to RBF. And um yeah, like I hope nobody like kind of quotes me and says like, "Oh, she's trying to strong arm full RBF," because like looking at many alternatives and would not move forward without good community support and understand of everyone understanding each other's um systems or each other's constraints. So yeah,
yeah,
just
sure.
putting that out there.
Yeah, sure, sure. And so I think, I guess let's go back to the broader topic around the
Mm,
mempool and packaging transactions together. I think what we're talking about, as I read you, as I understand you, this is about the long term functioning and scalability of Bitcoin, right? So high level today, a typical block may have something like 2,000, maybe 3,000 transactions in it.
yeah.
Now, if there's, every 10 minutes, 6 blocks an hour, but let's say we were to move into a world where many, many people are using Lightning and they've got their channels opens and closes and all of this, that's where this kind of thing would become a lot more important, as I understand it, because then if you are in a scenario where, you open these channels like 2 or 3 years ago, back when the fees were low and fees are consistently high, and now you're in a scenario where for your security, you are dependent on getting your channel closed, or let's say someone's trying to cheat you or whatever, you need to get your justice transaction or your penalty closed transaction.
Hmm.
That's where I guess this is more important. Is that
Yes.
is that how you're seeing it?
Yes, it's security is economics, right? So right now there may not be this attack might not ever I don't think it's ever happened, these types of attacks that we've described. And it's probably because there's not much value in these lightning channels. Like if you're able to steal an HTLC output, like what's that? Yeah, 20 sats. But in the future, when you have more money at stake, that bounty is higher. And if conditions change, like you said, you can have much fuller mempools, or a lot more channels open. So if there's like 50,000 channels that you can try to close that you need to try to close at the same time, like this attacker does it at a huge scale, there's not enough block space for all of those channels to be closed within a day, right? And so, this is all just trying to be forward thinking because protocol development takes a really long time. And these kind of security assumptions already don't hold true today, or, are at risk of not holding true today. But that's the thing to focus on, not the fact, oh, secure these attacks aren't happening, let's we can be complacent. No, it's these security assumptions need to be solid, otherwise you don't have the same security model on lightning as you do on L1 Bitcoin. And so that's we want this is kind of the remaining, I guess, like interface layer that we need to make sure is bridged properly. um, but yeah, so this attack is maybe more possible and more profitable in the future. And we need to look ahead to that.
Right. Okay. So maybe where, in terms of where we're at today with the different components. So I guess just to refresh my memory, one's called package relay and the other's called Mempool accept. Was it, or could you just
Yeah,
explain for
package
me?
mempool accept.
Yep.
So kind of the crux of package relay is having safe validation logic that is resistant to pinning attacks, is resistant to other types of censorship, that can handle arbitrary sets of transactions. Because when you're looking at n transactions, that can be very different from looking at one transaction. And so just figuring out all those things. And then we're kind of fixing a lot of the RBF issues along the way, because the goal, again, is to make something that works. And so that's package mempool accept, all the mempool logic. And then package relay is kind of just, what's the most bandwidth efficient way for two nodes to talk about packages where we're not, significantly increasing the amount of network bandwidth that we're using on the network. So, for example, we want it to be such that one node only ever downloads a transaction once. If in package relay they end up downloading the same transaction multiple times, that's bandwidth waste. Same thing of like each peer-to-peer connection should only talk about the announcement of a transaction once. And if package relay means that you're going to announce every transaction once and then every transaction in the package once, then that is also quite bandwidth wasteful. And so kind of the discussion right now is like, okay, how do we make this such that we can discuss new information without using extra bandwidth, as win-win as possible, as we've discussed. And so that's gone through a couple iterations.
I see. Yeah, yeah. I think it's fascinating stuff. And also, if you could explain one other part, I was just reading in your email. It's got WTX-ID based relay. So what is a WTX-ID, and why is it done on this basis?
Right. Yeah. So WTXID is as opposed to TXID. So pre-SegWit, we had a TXID where you hash all the parts of the transaction. And post-SegWit, you need a new hash, a way of hashing these transactions because the witness data can change even if the inputs and outputs and version and whatnot don't. And so you might have two transactions that have the exact same TXID, but different witnesses. And actually, one transaction could be valid and the other one could not because the witness data is, the signatures and stuff, right? And so this is quite significant in peer-to-peer. So we moved to WTXID based relay because there was a censorship possibility. So here's how transaction relay works. I'll announce the hash of a transaction to you first. And then if you already have it, then you'll drop it. And this achieves the goal of, not downloading the same transactions over and over again. That's a waste of bandwidth. And so if you don't have it, you'll ask like, hey, get data
Yep.
of this, thing that you announced, and then also need the transaction. But if we're using TXID-based relay, I can censor a transaction by sending you the TXID of that transaction. And then I send you like an invalid version of that transaction. And then you're like, oh, this is wrong. I'm going to throw it away. And we also have a rejected filter. So for transactions that we've already seen, we probably don't, it'll roll block to block. But if it was invalid, then we'll throw it away, and we will also cache that we rejected this like within the last minute or so. But that's very dangerous because if you're only using TXIDs, then you've just censored the actual transaction by sending the invalid one first. And so it's very important to use WTXID based relay. It includes the witness data. So that's not ambiguous. It's like, okay, well, you sent me the invalid one. Well, this is a completely new transaction. And the one use case left for TXID-based relay is orphan handling. So an orphan transaction from the perspective of a node, I think you're nodding because you already know this, but an orphan transaction, it spends inputs, and an input contains a TXID and the index of the output vector. But it's by TXID, not by WTXID. And we can't change this because then, SegWit. Or it's a hard fork. So when we receive a transaction and it refers to an input of a transaction that we don't know about, we can't very well ask for the WTXID of that transaction because we only know the TXID. So then we'll go and ask, we'll be like, hey, there's this TXID, this transaction refers to it. I don't have it. You have this transaction? So clearly you must have this transaction. Can you send it over? And so that's kind of, that you can't really get rid of that because otherwise you would never be able to handle orphan transactions. And that can happen at any time because we'll have unconfirmed transactions that rely on each other. And there's no like network propagation guarantees because you have multiple peers you're downloading transactions from. And on a peer-to-peer connection, I'll always announce the parent before the child. So you won't have this backwards dependency like error. But, let's say, the both, like two nodes announced both to you, and you request it from both, and the guy who has the child is just faster. They have a faster internet connection, so they sent you the child, and now, nothing really went wrong per se, but you've received them in the wrong order. So you need to be able to handle the situation where you just got them out of order. And so you cannot just delete TXID based relay because we still have a use case for it. But with package relay, we can get rid of this because now we're able to talk about transactions as packages, and we can say like, oh, can you send me just the WTXIDs of all of the ancestors of this transaction? And then I'll pick the ones that I don't have, and then I'll request those from you. And so that's one other benefit of package relay, is being able to handle orphans without TXID based relay, in addition to all of the wonderful fee bumping improvements.
Yeah. And so what about from a backwards compatibility point of view? So let's say I'm a laggard. I don't upgrade to the latest Bitcoin core, but you're on the latest stuff because you're advanced. What happens then? Like when my node is talking to your node, like how does that? Do we just kind of drop back based on versions? And
Yes.
You have to speak to me in the old language because I'm a laggard and I can't speak the new language of package relay.
Yeah. So we just won't relay packages because I'll send you, when we're doing our version handshake, right? I'll be like, hey, I know how to relay packages. And then you'll be like, I don't. And I'll be, all right, fair enough. We won't relay packages. And then just, that's fine. And then just from an implementation detail standpoint, like, I think about this and it's like, okay, well, maybe I'll have a 0 fee transaction with a high fee parent. I'll just like, we'll have some logic so that I also won't announce those to you because I know you're not going to take them, or I'm not going to announce the high fee child to you because I know you're not going to take the parent.
Because I won't take the
Right.
package, yeah.
Yeah.
Right. But I guess
So
the hope
there's
then
that.
is, yeah. Right.
Yeah.
And the hope then is over time, enough of the network upgrades over to the new system, and then, okay,
Yeah.
everyone can speak package relay and everyone is kind of in the happy path, let's say.
Yeah. Yeah. And I think once we get to the point where maybe like 10 to 20% of the nodes do package relay, you should probably be able to reliably propagate 0 fee parents with high fee children. Yay.
Gotcha. And so that may also that may open up possibilities around what some of the scaling and lightning and other protocols do, because now they can take it to the bank now, right? Because they can say, oh, now we've got package relay out there. Now we can design our protocol in such a way that we can more reliably RBF. I guess that's how you would.
Yeah, exactly. So I think this would save quite a bit on fees for Lightning because they can put 0 fees on their commitment transactions. Because right now, essentially, I think usually you put like at least 10 sats per VByte or higher because you always want to overestimate a little bit just in case the mempools get congested. But anytime you overestimated, you're overpaying on fees. But with package relay, if they're like, okay, we'll just add fees when we broadcast, then you don't ever need to overestimate. You just put 0 on the commitment transaction. You have an anchor output, and then you add the fees at broadcast time. And that's just much much more. And then hopefully you don't have unused anchor output UTXOs floating around. So yeah, hopefully this is pretty
I
good.
see. Yeah, and so that opens up possibilities there. I'm curious in terms of non-lightning things. Do you see any implications there or any benefits, wins there?
Yeah, so I mean, this will just make CPFP more reliable in general. And, Lightning is not the only user of CPFP. Um, like I said, orphan handling should be better. We should have fewer orphans uh, if we're able to download packages at a time and not store, stuff. Um, but yeah, like this is, I think, something that has always been talked about as an improvement to Bitcoin Core before Lightning existed. Like CPFP was quite a few years ago. And at the time, they were already like, oh, well, now we should be relaying transactions as packages because we have these like dependency relationships and, fee rates should be assessed at a package level rather than an individual level. But it's just there's so many moving parts to consider, and it's become more and more important, and so people are prioritizing it more. But maybe back in the day, it's like, well, nobody's using CPFP, like nobody is, the mempool is never congested. Like this is not a priority, right? Like I said, there's always many bugs to fix.
Yeah, of course. And I think it's interesting because in some sense, some of the stuff you're working on, it's just not. It may not be relevant for years to come, right? We don't know exactly when, but it's kind of we want to have it when it comes because then it'll be much more comfortable to deal with it. Because then we'll have less people who are, let's say, getting cheated out of money on their Lightning channel close, or and it may make the user experience a lot nicer for people, as opposed to them having like a janky experience where like, okay, I thought I was on Lightning, but then like I got yoinked because there was like some exchange who dumped all these transactions in the mempool, and
Yeah.
then they just kind of took up all the capacity, and now I got, you know.
Yeah. And if you consider how long it takes to deploy something like this, right, you have several years of like research and development and design. And then after it gets merged, you need to release it. And then gradually nodes adopt it. And then you have a reasonable portion of the network using it so that, you'll be able to propagate a package. Like this can take many years. And so if something's going to be a problem in 3 years, we have to fix it now. Like we have to be working on it now. So yeah.
Yeah, interesting. Yeah, okay, cool. So I think those are probably the key questions I had. Was there any other key things you wanted to hit while we're here?
Not particularly. I already got to plug PR Review Club, so
Yeah,
hope to
okay.
see people
Let's
there.
do that then. So, listeners, make sure you check out Gloria's work. I'll put the links in the show notes, and check out the PR Review Club. Is there a website or anywhere best for people to go to follow?
BitcoinCore.reviews.
Fantastic. Okay,
Yeah.
Gloria. Well, thank you for joining me again.
Thank you for having me. This was fun.